File uploads can lead to path traversal attacks, where an attacker might be able to navigate to a particular directory or file that they shouldn't be able to. They can escalate their privileges and get access to sensitive parts of your server. The path traversal attack, also called directory traversal, is a vulnerability where an attacker manipulates a path input. So your application reads from or writes to a location outside of the intended or target directory. It is fundamentally a file system injection problem. Untrusted input becomes a part of the file path, and the attacker uses that to control or navigate to the server's directory structure. So the attack pattern looks a little like this. They'll upload a file, but they'll add all of that as the path, where they're using the // sequence to escape the intended directory. And the goal here is to read or write files outside of the intended or target directory structure. Now, the impact that this can have is they can overwrite app or OS files or expose system information, or it can enable remote code execution. When mitigating against these kinds of attacks, we have to implement certain measures like the principle of least privilege, where we ensure that the web app hosting account, or in Windows and IIS servers, the app pool identity, should write only to a designated upload directory, have no access to the www root or system paths. If we want to prevent path traversal, we can normalize paths using certain built-in functions. We can also sanitize file names and combine paths safely. Let's jump over to our files controller and review the vulnerable code and see what we need to triage. In this controller, we're setting the upload route to be some path where we're setting it inside of the content root path. And then we're creating a folder called app data and downloads. So that is the destination path. So if it doesn't exist, then we go ahead and create it. In the upload method, we're firstly making sure that our file has some data. Otherwise, we'll say bad request, you didn't provide a file. But then we're going to go on to upload. Now, here's the specific vulnerability that we're addressing right now, which is the file traversal, where an attacker can provide a file name with these escape characters. So each time you see .. it means I'm going to the previous directory. And if they provide enough of this and they know that they're dealing with a Windows system or a Linux system, they can deduce how that file system looks, how many .. need to be used to come out of the folder that the destination file is going to, and potentially go into the Windows and system folder, and then potentially plant some evil file in there. And then we're setting up the file name using this exact file name that was uploaded, and then we're putting it inside of that path. So all of this here introduces the potential for path traversal attacks. So in order to simulate this attack, we'll need Fiddler. Go to telleric.com/fiddler and you can try it for free, and it is available for all operating systems. And once you launch, it will actually start monitoring all of the web traffic on your computer. So you'll see this pane starting to fill up, but we want to focus on our API activities. So quick ways to configure this would be to go to the filters tab, enable use filters, then enable show only the following hosts, and then show the local host with the port of the running app. In our case, it is localhost : 5001. Once you click outside of this text area, it will commit that change, and then the pane should stop filling up as much. The next thing you want to do is enable breakpoints for when requests are going out. So you're going to go to rules, click automatic breakpoints, and then you're going to enable before requests, or you can just press F11, or you can click in this section right here. It's not very intuitive, but I prefer to just go to rules, automatic breakpoint, so I know exactly which one is enabled when. So once you have set up Fiddler, you can launch the API. You may notice that the Swagger page is failing to load, and if you open Fiddler, you see that it's hitting that automatic breakpoint. So I'm going to disable the breakpoint for now by just clearing it out of that section of the window. And once Swagger loads, then we're good to go. Now, I'm going to try a file upload. And I'm putting in a valid patient intake ID. And if you're not sure what the IDs are, you can always go to the intake/search and you'll see the different IDs. And I'm uploading a file, simple file, test.txt. So when I execute that, I get a 201 response. If I go back to Visual Studio, I will see the new folder created, app data, uploads, and test. Now, if I want to perform a file traversal, the good thing about the operating system is that it limits the characters I can place in the file name. So I cannot just go and change a file name like this. That is, well, a good line of defense. But using a tool like Fiddler, I can actually intercept the request. So now I'm going to, in Fiddler, clear everything out, and then I'm going to re-enable the breakpoint and go back, and I'm going to submit the same request. This time Fiddler intercepts it. And if I click on it and go to inspectors, I can then see the details of the request. Right here, you can see headers, text view, syntax view, etc. From the raw view, I can look at the content being submitted. Now, if I introduce a dot dot slash in front of the file name and then click run to completion, it will complete the operation. And if I look in the file system, this time test.txt ended up in the folder. So we have finished then src, and it ended up in a folder or directory that is completely outside of the API directory, which is the directory that has the app data, uploads, and the destination. So right there, I was able to plant a file in a place that it should not be planted. This is a very simple demo, of course, but I'm just showing you that it is a very real attack. So we need to triage that. Now, ground zero for this attack is the fact that we are retaining the original file name. So the file name that came in through the request, whether it came directly from the form or it came from Fiddler in our situation, we don't want to keep it. So here you'll see the suggestion is that because there's no GUID or sanitization, there's an issue here. So the first thing I'm going to do is retain the path extension. So now I know what extension it should have, but I'm now going to create that stored file name to be a new GUID with that file extension. So I'm no longer going to care about whatever name you called it. I am now going to give it its own name for my storage purposes. That being said, if you have to store it in the database later on and upload the record, you can have the original file name, which is whatever was uploaded, but then we're going to store it using our own internal standards. Now, after that, we go ahead and we do a file combine. Now, I'm going to go ahead and get the full path. So the full path here will be whatever the file path is, which would be everything the directory up to the file name. And then as another safety check, I'm going to say if the full path does not start with the upload root folder name, then we're going to log the security breach and return bad request. So no matter what, even if for somehow we ended up with a different file path from the upload root and our newly formed file name, we're still going to make sure that our destination is at the minimum the upload root folder. And now that we've added that fix, let me go ahead and run. And remember that we need to disable the debugger until we're sending the requests that we intend to evaluate. Let's try our upload again. But before I submit, I'm going to re-enable that debugger just to make sure I intercept that traffic and let's clear just to make sure we have a clean slate. Execute. Let us fiddle with it again. And I'm just going to do dot dot slash. I think that's enough. It means it will go to a different directory and then run to completion. We get our 201. If I jump back over to the code, I'm now going to see that I have a different file name altogether. It's now just a GUID with the extension. If you use SQLite Manager and check the database, you will see the originally submitted file name as well as the new file name.